want to talk to you about number 17 from the homework from yesterday. This was the cereal box example with Tiger Woods and David Beckham and Serena Williams. And in this example, you had to come up with a way to simulate, a lot like what we did with the Toy Story example. It's actually almost exactly the same. I was looking back over the Toy Story lab that we did in class, and I noticed that a number of you did a very good job of writing down the different elements of the simulation, all 7 pieces of it. Even if you combined some piece steps, you did a good job, and some of you did a very horrible job. In fact, complete steps were completely left out, weren't even addressed, not even mentioned. Conclusions left completely off, and I took off points for that. On a quiz, that's going to count a lot more off than just on a daily homework. So I wanted to go through this one more time, and if you didn't write down notes the first time, apparently some of you didn't, because you had no idea what you were supposed to be doing. You did your simulation, you wrote down what your results were, and that was about it, and that won't cut it. So you pay attention when we go through this. The example was, and I'm not going to read it to you, but it was talking about you had 3 toys or 3 cards in cereal boxes, and you wanted to figure out is if you bought 5 boxes of cereal, then what was the likelihood that you could get all 3 cards in just buying 5 boxes? And the question said make sure that you do at least 20 trials of this. All right, so here's what should have happened. There's 7 parts that we want to talk about. The first thing is to identify what you're going to be doing and what is the simulation supposed to represent. This is theoretically. This is not actually. We're turning numbers over. Yes, yes, yes. But we're actually going to be supposedly opening these imaginary boxes of cereal and looking at the card inside. That's what we're going to be simulating. Part 2 was, all right, well, let's go ahead and divide up my numbers. And I think most of us got this because you really couldn't do the simulation without doing this. And since based on the probability, Tiger was 20%, then 30%, then 40%, or 50%, excuse me. And so you had to make sure that the numbers matched up with the percentages. In this case, they were all multiples of 10, so that made the division very simple. And so if you go through that, you can divide them up this way. The next part was to give me a very good summary of what was supposed to happen. And there were 2 things I really am looking for here. Is number 1 is what does a trial consist of? Like, when do I know that I'm finished with my trial? Because I'm supposed to do 20 of these trials. When is it finished? Another thing would be to comment on if you're allowed to repeat numbers or not. Okay, in this case, it was pretty obvious when we're supposed to stop because we're just going to be collecting 5 numbers at a time and seeing if we got all the cards or if we didn't get all the cards. Previously, you were going to pull boxes and you're going to open boxes until you got all 4 cards. So the number of boxes in each trial was never defined. In this case, it is defined. So we'd write it out like this: each trial will consist of 5 random digits, and we're going to allow the repeats to happen. And in that case, this is kind of the way this one's set up. I didn't really need to do anything else. And so, number 4, we kind of wanted to summarize, I guess, the probability, how the simulation is going to work out. What am I looking to collect, and what am I going to be counting? And so the trials, where each one is collected, where you get each one of the cards, then that's going to be considered a success. And what we want to do is we want to count how many times do we have a successful run and divide that by the total number of trials that we ran. In this case, it'll be divided by 20. Next step would be just to run the trials. I didn't include all that information here, but you would use a number table, which you're going to have to do that today if you haven't already. I explained that yesterday. And so you're going to have to do that on the sheet that I'm going to pass out in a little bit. Or you can use your calculator to simulate those probabilities of those random digits. In this case, on question number 6, we're supposed to calculate whatever number it is. In this case, we're not necessarily conducting an average, but it wanted to know a probability. How many times did a certain outcome occur? In this case, in my case, 11 out of the 20 times it occurred, and so that would have been a probability of 55% or 0.55. Theoretically, should be somewhere around 51.5%. Now, that doesn't mean that you have to get close to that number. Sometimes you can be fairly far off, depending on how big a sample size you took. Last step would be to summarize your results into a plain English version, not the statistical jargon that you could say. According to this simulation, my probability of getting all the cards out of 5 boxes is 55%. You want to make sure that you're including these steps, because when I go to grade your quiz tomorrow, then I'm going to be looking to find each of those pieces. Now you can combine, like number 6 and number 7 could be definitely combined into one step. Just make sure that you're writing these elements down. No big deal, but a lot of you did a very, very poor job on doing that last time. I've left a worksheet for you to work on. This is kind of similar to the quiz. It's a lot longer than the quiz. The quiz won't be this long. But I want you to take a minute. It's got some multiple choice questions, and it's got a couple of short answer questions. Work those. You will be turning those in for a grade. Okay, so make sure that you complete that. If you don't finish it in class, it is for homework. You have the rest of the class period to work on it. You should be able to finish it in class. Some of you got some catching up to do, so good luck.